Okay, so this is week 11, Wednesday, semester 2, quarter 4 on geometry with angle pair relationships. So let's go ahead and take a look at the answer here. So this one says name the relationship, complementary, linear, vertical, or adjacent. Hold on a second. I feel like we did this one. Okay, we're going to switch over a little bit today. We're going to go over Quentin's math for week 11 Tuesday, or not Tuesday, actually. It should be Wednesday for the math challenge for March of 2024. And then we're going to start at question number 11. Quentin, go ahead and read that, please. Okay, so area means you're going to multiply. It's like, how much wrapping paper do I need if I need to cover this? Or how much paint do I need, right? So what is, hold on a second. I need to take a better look at this. What is this say right here? What is that number right there? 6. Okay, what is that? Does it say anything about that right there? It doesn't say any. Oh, but this right here is 4 because this part is 4. Do you see that? Okay, so let's go ahead and find the area of this triangle first, okay? So the area of this triangle is going to be 6 times 4 times half. Okay, that's the area of a triangle. 6 times 4 times half. 6 times 4 is 24. What's half of 24? Yeah, so that's the area of that. That's 12. Okay, so we're just going to leave it there. Now what we're going to do is let's go ahead and take a look at this little rectangle right here. Do you see this rectangle right here? Okay, that rectangle is going to be 2 times 6. So 2 times 6 is? So 12. That's another area, okay? Our next area they're going to focus on is going to be this part right here, okay? This right here is 4. This part right here is 3. So 4 plus 3 is this entire thing is 7. And this part is 4. Do you see that? So it's 7 times 4. Good. That part's 28. And then all you're left now is just this tiny little rectangle right here. So let's take a look at this. This part is 2. That part's 3. So what's 2 times 3? Okay, so now you're going to do, you're going to add everything together. 12 plus 12 plus 28 plus 6. What is that going to give you? So add everything together then. What's your total? Centimeters squared, because it's area. The squared is a little 2 right there. You have to put the little 2 on top. Cube is volume. Like how much water would you pour into something? Okay, number 12.
Rectangle stone is divided equivalently into 12 squares. So the 12 squares has an area of 25 inches. What is the perimeter of the rectangle?
Okay, each of the 12 squares has 24 square inches, so that's 25, right? Just kidding. So remember, if that's going to be 25, then what's the side of one of these? 5, right? Because 5 times 5 is 25. So that means this is 5, this is 5, this is 5, 5. You gotta rewrite, you're gonna write it around the rectangle. How many 5s do you have there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Times 14. So what's 5 times 14? 70, which is inches. That's your answer. Okay. Yeah. Number 13. Go ahead.
A three-dimensional object can be represented by different perspectives from above, okay, the front view, and from the side, typically right side. The figure shows you an arrangement of cubes. What is the greatest number of cubes that could be the arrangement shown?
Well, at the front has 1, 2, 3, 4, 5, right? Top was 1, 2, 3, 4. The right side is 1, 2, 3, 4, 5, 6, right? I think maybe we should just time them together. What do you think? 30 times, I don't think that's right. Maybe 120. I'm just saying 120. I don't know. I just put 120. Yeah, I don't think that's right, but I don't have the energy to. Okay, so you could try it. Why don't you try it? This is the right side, which means the left side will also. So the right side has 6, which means it's 6 times 2 because there'll be 2 sides, left and right, right? Front will also be times 2 because of top and bottom, right? Front and back, right? So right and left. So that's 10, right? And then top will be 1, 2, 3, 4. So times 2 is 8 because there's a top and a bottom, right?
And so, do we multiply them or add them?
But then you're gonna have some spaces in between them, so I don't really know, Brendan. I don't know. I'm gonna add them all together, which is gonna give me 18 plus 12, which is 30. And I don't know how much is in between, so maybe just times it by 2 and like double it. Or you can, I don't know, you can put 30. $14, go ahead.
Along diagonal, like
Diagonal.
diagonal of a rectangular hexagon from vertex to opposite vertex measures 28 millimeters. How many millimeters are in the perimeter of the hexagon? So
Perimeter is this part right here. Right here, like that, right?
Mhm.
You know that this part right here is 28. So if you look like this right here, do you see I'm breaking this down into 3 triangles? So what's 28 divided by 3? Well, no, divided by 2.
So 28 divided 40.
14. So this is probably 14 and this is 14, right? And this is 14 because the triangles are the same. Do you see that?
Bottom.
So then that means this is 14, 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 this is 14. So your perimeter is 14 times how many sides are there? Okay. Millimeters is your unit. Okay, good. Number 15, go ahead.
Wait, milliliters.
Millimeters.
Yeah.
Go ahead.
16 and times, wait, x, wait,
A 16 by 16 square.
8 squared. 1.5 to form triangle. The triangle is folded in half again 3 more times. If the paper has a side length of 16 inches, what is the area of the last triangle?
Okay. So this is folded in half. So this is the first fold, right? And then it's folded half again 3 more times. So 3 more times, so it's gonna fold half again. This is in the triangle right here, right? That's 1 time. Half of that is 2 times, and 1 more time is 3 times. So we're looking at this triangle like right here. Do you see that? Okay, so we're gonna find the area of that pink triangle. So what we need to do is, you know that this right here originally is 16, correct? 16 for the whole thing. So then when you, let's see. So let's take a look at this. from here to here is 8, right? And then the height, let's see. Yeah, that is kind of, oh, the height is gonna be right here, I believe. I think, I'm not sure. 1, 2, 3, 4. So let's do 8 times 4 times half. What is that gonna be?
16.
Okay.
I'm like, wait, I know this. Or maybe it's 36. I was not sure.
Okay, all right, like next page, here we go. We're gonna go on to number
What?
16, I think something squared, inches, yeah. Because of the area. Okay, how many questions are there?
You're always gonna be
I need to take a look at your paper because I don't have the 18. Let me see your paper first. All right. No, stop. All right, hold on a second. Okay, here we go. All right, so now let's take a look at this. Okay, 3 more questions. Let's go ahead and finish this. Okay. All right, so read question number 16.
a regular hexagon and a regular octagon, both number sides have the same perimeter, which is between 80 centimeters and 100.
Mhm.
What is the number of square centimeters in the area of the square that has the same perimeter as the octagon and the hexagon? Question mark.
Are you kidding me? A regular hexagon. So a hexagon is going to be 6-sided, right? And a rectangular octagon, which is 8, right? Both when whole number sides have the perimeter between 80 and... Okay. I don't know. I'm just gonna put question mark. Okay, next question.
What?
Number 17. I just put a question mark. Go ahead. Yeah, I don't know. A square with a sine length of 5 is positioned with its corner. Okay, great. Okay, so that's 4. One side of the overlapping region is equal to 3. Find the area of the overlapping between the 2 squares. Okay. Okay, so one way that you can do this is we can first try to find the area of this yellow triangle. Do you see this yellow triangle? It's kind of hard to see, but can you kind of see it? Okay, great. Because all right, the middle of this is going to be, this part right here is half of 5. Do you see that? So that's 2.5, okay? If this entire thing is 3, I'm assuming that this part is also 2.5, maybe? Maybe, I don't know. Maybe 2.5? Wait, 3, hold on. Oh, this is 3, this is not 5, this is 3, 2.5. You can do something, but give me a second, let me finish this. So this part right here is 2.5, this is 3, this part right here is gonna be half of 4, so that's gonna be 2, right? Yeah. I'm just gonna do some crazy math with you, okay? So 2.5 squared minus 4 square root of that is gonna give you this part right here is 1.5, okay? Which means this part is gonna be 1.5, so the whole thing is 3. So 3 times 2 times 0.5 is 3. So this triangle is 3. Now we need to find this square, this area of the square is going to be 2 times 2, which is 4. But then if I can find the area of this little piece right here, that green triangle, and if I can find the area of this orange triangle, hold on. If I can subtract that from that square, then I will be able to find this piece right here. Do you see that? Okay, so that whole thing is 4. So then, I don't know, this is gonna look weird. I know this is gonna be, careful, Emma, I don't want you to fall down, baby. This is 2, base is 2. So 2 times 2 times 0.5 is gonna be 2. So that's gonna be 2. Hold on, I'm trying to figure this out. This piece right here is 2 times this piece, 1.5. So 2 times 1.5 times 0.5 is 1.5. Hold on, 4 minus 1.5 minus 2, that is going to be, this piece right here is going to be 0.5. So then let's add everything together. I'm going to have, and now I'm confused. Hold on, let me erase this so I can see better. So I found that this triangles, hold on. So I have 3 plus 1.5, 3.5. Just put 3.5. I think it's 3.5. I don't know for a fact, but 3.5. And you could put, yeah, it's just, there's no unit. All right. Question number 18, last one. Go ahead. Go ahead. Go ahead.
Sorry. For here, wheels on fixed
Axles.
axles are next to each other. The first wheel has 30 feet, the second one has 50 feet, the third one has 60 feet, and the last one has 10 feet. How many revolutions does the last?
I don't know. I'm done. I don't care about this question. All right, we're done. Bye. Just make a guess.